Okay, so this is our final lecture for the course, and it is a beauty. It is a magnum opus for us. I will tell you, I still have several happy family members in the background making lots of noise, and I'm not going to ask them to be quiet. So hopefully the background noise is not too distracting. We have an interesting topic here, some that may carry us through. We're going to talk about pH. Yes, pH, and I am looking forward to it because it's cool. We can gain tons of insight by just a little bit of notation and a little bit of math. So first of all, let's give a definition. The pH scale is used to describe the acidity of solutions, and it's very important for lots of things. Okay, pH is used to describe the acidity of solutions. So here's a picture of a dipstick being used to measure the pH of a urine sample. Urine, blood, uh, foods, drinks, soils, lots of medications, lots of things. The pH matters very much. So our learning goal for this section is to calculate the pH given the concentration of hydronium ion, or given the pH, calculate either that or the hydroxide ion solution, the hydroxide ion concentration in solution. Okay, so let's go back and look at this now. The pH of a solution is used to indicate the acidity of a solution. We just said that. It has values that usually range from 0 to 14, right? I used to think it was you can't go below 0 or you can't go above 14, and that's not true, but it's almost always between 0 and 14. And it's acidic when the values are less than 7, and it's neutral when it's at 7, and it's basic when the values are greater than 7. Okay? And just sort of a mathematical restatement of what we have above. If the pH is less than 7, that means the hydronium ion concentration is greater than 1 times 10 to the negative 7, right? And this sort of gives us an idea of what the formula for pH is. If it's 7, this way we could tell, you can imagine what the formula for the pH is, right, by looking at that. But I'm not going to ask you to recognize it. I'm going to simply tell you what it is. So a little more on pH. First of all, the pH of a solution can be determined a few different ways. We have pH meters, which where you take a couple probes and stick it in the bucket and you show the pH. You show the pH. There are pH papers, right here. You stick it in there, and if it's red, it's a basic, or rather, it's acidic, and if it's blue, it's basic. If it's really dark blue, it's really basic. Okay, and we also have indicators. Put a little drop of something in there, and if it goes red, it's acidic, depending on the indicator, right? So it makes different colors for different pHs. Okay, the pH of some common substances look like this. It's if you have a 1 molar HCl solution, the pH is 0. The pH of the juices in your stomach is 1.6. The pH of milk is 6.4. pH of urine is about 6. An orange is about 3.5. Coke is about 3. Vinegar is about 3, 2.8. Apple juice is 3.8. Tomato juice is not quite as acidic. Coffee is pretty acidic, 5. A potato is also a little acidic. Pure water is supposed to be 7. Drinking water is about 7.2. Your blood is 7.4. This is interesting, isn't it? Milk of magnesia is 10. Ammonia is 11. Bleach, 12. Yuck. And 1 molar sodium hydroxide solution, which we call lye, is 14.0. And by the way, notice that the shape of this bottle is like Drano, right? Because that's what it is, Drano. It's not 1 molar. Drano is actually much more concentrated than that, and it has a pH that's outside the range of 0 and 14, funny enough. Okay, so identify each as acidic, basic, or neutral. Pause the video and come and look at this. And then come and look at my answers. Pause the video and make a guess for each of these. Okay, so HCl, hydrochloric acid, is acidic. Pancreatic fluid, which has a hydronium ion concentration of something less than 1 times 10 to the minus 8. This pancreatic fluid is going to be basic because 1 times 10 to the minus 7 is neutral, right? And minus 8 is smaller. A soft drink, pH 3, that's acidic. pH 7 is neutral. the hydroxide concentration is smaller than 10 to the minus 7. And so this is going to be acidic. And the concentration of hydronium is smaller than 10 to the minus 7. And so this is going to be basic. All right. Okay, so let's show you how we're going to calculate this. So the pH scale is a logarithmic scale. I wouldn't get too worried about that. We're going to need to use it in a calculator, but it's a logarithmic scale that corresponds to the hydronium ion concentrations in aqueous solutions. And it's the negative logarithm of the concentration of H3O+, right? So pH is defined. That's just a definition as the minus log of the hydronium ion concentration. To calculate pH, the negative powers of 10 in the molar concentration are converted to positive numbers, right? But we're also going to just stick it in our calculator some, right? So look at this. The negative log of this is by definition. The negative log of this is going to be the negative of minus 2, because the log of 10 to the minus 2 is minus 2, right? You get that? The log of 10 to the minus 2 is minus 2. That's it, right? So the pH of a concentration of 1 times 10 to the minus 2 is going to be 2, period. That's it, right? So I just went over this in the previous slide. I'm not going to, I frankly don't care about 2 sig figs here, or the number of sig figs. So really what we care about is this part, that 2 goes to here, okay? And so let's do a couple of these. Because the pH scale is a log scale, a change in one's pH unit corresponds to 10-fold change. This is going to be really difficult, I think, to appreciate. I should say it, but it's going to be difficult to appreciate until you do a bunch of calculations. And the pH decreases as the hydronium ion concentration increases. So a pH of 2 means your concentration of hydronium ion is 10 to the minus 2. pH of 3, it's 10 to the minus 3. You get what's going on here? 4 is 10 to the minus 4. I'm sort of restating what we've said a couple times now. All right, so let's calculate one. If a solution, aspirin, acetylsalicylic acid, was the first NSAID drug to use to alleviate pain. If a solution of aspirin has a concentration of blank, what's the pH? All right, so we're going to say pH is equal to negative log of H, the hydronium ion concentration, right? 1.7 times 10 to the minus 3. So it's going to be close to minus 3, right? Because we got minus 3 here. It's going to be close to minus 3, but not quite, because we've got this 1.7 here too, right? So I'm going to put this in my calculator, and we're going to find that it's close to minus 3. Here goes. Log, I'm going to say negative log 1.7 times 10 to the minus 3. And it's not trivial getting this in your calculator, I know, but you do need to do that. And as I said, it's going to be close to minus 3. It turns out it is 2.77. 2.77, right? So it's close to minus 3. Very good. So let's do another calculation. Oh, I just did that one. 2.77. Okay? Let's do a learning check. Now you do it. Pause the video, calculate this, and come back and compare your answer against mine. Okay, so let me suppose you paused it, and we know that pH is equal to minus log of that stuff right there, right? And it looks like the pH is going to be close to 5 because it's 10 to the minus 5, right? So let's put it in our calculator. It's going to be close to 5 minus log 4 times 10 to the minus 5. Did I get that right? I did. Okay, it comes out to be 4.4, 4.39, 4.40. So this is equal to 4.40 times 10 to the 0, right? That's it, 4.40. And that's the pH. Okay, so let's do another one here. Similar issue here. Now we're going to say we're going to calculate the pH from the concentration of or calculate the hydronium ion concentration from pH. And so it's just you learn this in a math class, which is required for this course, but you may not remember it. And that is the inverse function of logarithms is 10 to the blank, right? So this is the same thing, but backwards. This is implied from pH is equal to the minus log of the hydronium ion concentration, right? That's how logarithms work, okay? These two are the same function, but written backwards. All right, so we're going to say that we have that in our head. Write this down. H3O plus is equal to 10 to the minus pH. And so tell me, pause the video, and determine the hydronium ion concentration for a solution that has a pH of 3.42. Okay, I'm going to suppose you paused it, and I'm going to invoke the definition. That is equal to 10 to the minus pH. Great habit to always write the rule out first, right? So this is going to be 10 to the minus 3.42. And I've got a key in my calculator that has a 10 to the blank, right? On my calculator, that's blue. 10 to the minus 3.42 gives 3.8 times 10 to the negative 4 equals 3.8 times 10 to the minus 4. All right, and there we have it. Hope that's helpful. We'll get some practice with this in our homework. Good luck.